Hello, and welcome to the first of a three-part webinar series. Today, we will be exploring the future of facade design. From undulating forms to breathable qualities and sustainable fabrication, the future of facade design is an ever-evolving topic in architecture. Design Boom and ArchDaily have teamed up to discuss the future of cladding, including the digital and sustainable fabrication of facade panels, together with Corian Design. Corian Design, a business of DuPont, is a leading surface manufacturer and service provider who aids architects and designers in realizing creative visions, much more than solely exterior cladding. As such, Design Boom and ArchDaily are set to moderate and broadcast an exclusive yet free three-part webinar series with Corian Design. Today, in our first of the series, this webinar aims to explore the future of cladding. Welcome everyone, and thanks for joining from all corners of the globe. My name is Kat Barandy, Design Boom's Senior Architecture Editor, based in New York City, and I will be the moderator of our conversation today. I'm joined by a panel of creative experts from international acclaimed architecture practices: Filippo Innocenti, Director at Zaha Hadid Architects, Marie Lucas, Partner at M3 Architects, and Sanya Kovacheva, Architect at STARH. Each expert will not only add their and their practices voice to the future possibilities of facade design, but also add shape in the form of realized case studies made possible with the aid of Corian Design. We are also connected together by Paco Ledesma, technical specialist at Corian Design, who will give further insights into their product and services that have and will enable creatives to shape this future. Before handing over to Paco, I'd like to remind our live viewers to add questions for our experts in the Q&A section in the toolbar below. We'll answer a selection at the end of the conversation. Paco.
Thank you, Kat, and hello everybody from Barcelona, Spain. My turn now to introduce a little bit Corian to all of you. You probably all know Corian, but I'm going to spend like 3-4 minutes just explaining a little bit of the basics. Corian solid surface was invented back in 1967. It was the first ever solid surface material. Corian is a composite material made with acrylic resin, aluminum hydrate, and pigments. It's a solid product. All through the thickness, it's non-porous, has the same color, is the clean, low VOC, resistant, and durable, and can be fabricated pretty easily with seamlessly and thermoformed. For more than 50 years now, Corian solid surface has been trusted by thousands of new architects around the globe because of its unique features and aesthetics to take design into unique directions, putting together high performance, beauty, providing new solutions to commercial spaces like in healthcare sector, hospitality, retail, and also into residential spaces like kitchen and bathroom, mainly. Because Corian is non-porous, it's seamless and low VOC, it helps taking care of what's more precious to us, what's more important to us in reality. It's our health and where we live, the environment. Just an example, in these recent COVID times, where clean and healthy surfaces were key, we could show that the material combined with regular cleaning and disinfection is probably one of the best ways to eliminate traces of virus and bacteria from any surfaces that you would touch. On the environmental side, our materials are designed to be durable and sustainable. It's very durable, so a longer inherent value is key in circular economy. And their Corian solid surface enables to repair, to be repaired, to be reused, to be upgraded, and to be refurbished. So it's designed to maintain operational utility much longer than many products. Corian Design delivers superior finished products through a network of highly skilled fabricators, certified and trained by us, the support of its internal technical experts, and also a 10-year limited warranty. The technical team, of which I am part of, can provide support to fabricators, to architects, project managers, etc., at any stage of the project. Now, talking about the topic of this webinar, you know that Corian solid surface, as it was mentioned, it's also used for facades. We'll see some examples right now. Because of its intrinsic material characteristics, Corian allows to make a statement in new projects by creating unique, long-lasting facades. And when we say long-lasting, we really mean it. Just to give you an idea, the first examples of external claddings with Corian date back from 1987 in the UK. Corian makes it possible to create 2- or 3-dimensionally formed facade sections to achieve complex geometries with one of the biggest seamless panel sizes in the world, and allows also to express your creativity. No limits, that's what we say, and we try to really stick to that. Exterior cladding solutions with Corian that can last a lifetime thanks to its high performance, durability, excellent UV resistance, and weather resistance also, easy maintenance and repairability, with a reliable structural performance and a certified fire rating of the material. This was a short introduction of Corian, and now I hand it back to Kat, who will introduce you to the rest of the panelists.
Thank you. Now we'll explore a selection of facade projects by our guest speakers together with Corian Design. This includes the idea behind each project, why Corian has been used, and what features and benefits of the material are most important. So I'll share screen, and beginning with Filippo.
Thanks, Kat. Good afternoon, everyone. Thanks for joining the webinar. I'm Filippo Innocenti. I'm director at zaha hadid. I've been working with zaha hadid architects since 2002. And I started working mainly in the cultural field, but then evolving into transportation with the design of a number of stations and airports. And lately more and more interested into how to shape the public space and how this could affect the transformation of our cities. The project you're seeing here is one of our most important. This follows the competition that we've done back in 2003, is the high-speed train station of Naples in Italy, one of the stations along the Italian network that connects the north to the south, and in particular the north that's from where the line departs towards the southeast of the country. When I started doing this project, I had joined the office for about 1.5 years, and the next one, please. At the time, so yes, thank you. At the time, the office was pretty much busy. Our agenda was all busy with the exploration of complex form, and we were looking at alternative way of design a facade that could be in a way at the same time competitive, but alternative to more established traditional form of modernist architecture. And in particular, we were looking at how to make use of the available construction technology at the time to build facade that could be curved in many different complex forms. Of course, we were limiting our, let's say, catalog of panels and shapes to what was available at the time. And so we were restricting to either planar surfaces with either simple or complex shape, or a portion of simple repeatable geometry like cylinders and cones. And so we were venturing for the first time with this project into the exploration of the first surfaces in torsion. Next slide, please. So this experience was coming from a couple of projects we've done before than this, and in particular the Landesgartenschau we designed in Wallenrhein in Germany, and Museum of Contemporary Arts in Rome. But what we were exploring here with the station in Naples was the first opportunity to create and build double curvature panels that would allow torsion in the facade. So this was one of the typical tools that we would have used at the time to catalog and classify all the different shapes of the panel in order to keep track of the complexity of the facade and at the same time maintain it within the expected construction budget. So at the time we were desperately looking for a material that could have served the purpose of being easily cut, easily transported and installed, but at the same time allowing for curvature and to be bent into shape. So when we, for the first time, explored the opportunity that Corian was promising for the external facade, we were very, very interested. And I believe we've been one of the first offices who have attempted to take advantage of these unique characteristics. The next one, please.
Well, and just so you know, it's 5 minutes, not 10 minutes.
Yeah, no problem. I'll be very quick. So this is the project. As you can see, it sits on the outskirts of the city of Naples and is a cross station. It's being conceived as a bridge over the railway line with the idea of resolving the issue of the barrier that the infrastructure creates within the territory. The concept of the station is to bring the passenger center right on the top of the platforms, with the advantage of being in the ideal position to distribute the people towards the platform and to let them interchange within the different hub. Now, the advantage of a bridge that is conceived as a the station that is considered as a bridge is that you can orient the main body of the station with the ideal position with respect to the sun. So the next one, please. This has been one of our first sustainable building. At the time, we were very, very keen on establishing the first bioclimatic principle and trying to reduce the amount of energy used in the building with the solar exposure, with the control of the solar exposure, which is particularly important at this latitude where the building is exposed to a significant amount of solar energy for a considerable part of the year. The next one, please. So this is one of the images of the interiors of the building, which is conceived as an overall atrium that organizes the passenger center right on top of the platforms. And of course, the control of the energy intake through the main glazed roof is one of the most significant aspects of the project. As you can see here, the shape of the roof is such that is orienting a number of sides towards the north. So regardless of the distribution of these panels, glazed panels along the roof, it always allows the best intake of solar energy, the minimal intake of solar energy, and the maximum amounts of natural illumination. The next one, please.
Just a reminder, you've had about 5 minutes now, so.
Yeah. So, well, this is one of the image of the southwest entrance. We can see here how the Corian panels have been extremely helpful in resolving the problem of the outer envelope of the building, allowing us to follow the curve of the overall geometry of the external volumes And the next one. On the same time, having both a number of complex shaped panels, but also bends into single curvature elements. The next one. Or like in the case of the east entrance, how to be properly bent over the curvature of the main steel structure. And the last one. And again, another image that is showing how flexible is the use of this material when it comes into allowing the definition of very sharp and on the same time curved elements that might be needed. One of the great advantage of the material we found is the opportunity to be cut and treated as in a very similar way to wood panels. So with a very basic kind of technology, it can be assembled, glued together. The perfect continuity between two panels can be perfectly reestablished. And on the same time, it can be bent at very low temperature without the needs of a counter form. It can just be heated up and then let it adapt to one single mold on a single surface, for instance, without the need of the complex molds. So these are all characteristics that have been that reveal being extremely helpful in the management of the construction of this envelope that could be controlled directly on site with minimal investments into specific technology. And this is pretty much it. I'd be happy to respond to any query should be posted.
Thank you very much.
Thank you very much.
Next, Marie.
Hi, I start directly, so I gain some time. So, thank you for the invitation to present in behalf of my firm. This small building in a way, but we like so much. The project we present today is the Hotel Mama Shelter. It's located in the very heart of the so-called European district in Luxembourg. And so it's surrounded by many office buildings. In the background, you see the towers of the European Court of Justice. My goal was to give the facade a visual differentiation from the urban context and to make it really look different and clearly distinguish the function of an hotel and its life inside from the office life. And you see in the back the other building we built on the same side with a black facade in contrast in the back. And I see that the surface mentioned for the project is the whole mixed use program on this side. Next. So you see both buildings are linked by a public square and a street on the other side and an underground parking lot. The hotel has 5 floors of identical rooms. Next. You see, this is a very typical hotel plan. Mama Shelter is a new brand issued by Trigano, but the rooms are quite small. It is mainly aimed at young urbanites who prefer to spend more time in the public rooms on the ground floor, the restaurants, and also a big co-working space in the basement. So with this very strong rhythm and with this repetition, we decided to play and to make something playful out of this repetition. So, and there was also another reason, because those small rooms are also quite comfortable. Next. And to illustrate this, this was the first logo of Mama Shelter hotel, how do you say that, chain? And it expressed also something from comfort and care. And we used a lot the idea of the feathers to convince our clients on the facade. It was something like a storytelling about additioning elements, comfortable elements and feathers. So to escape monotony, we decided to articulate these elements of the facade. Next. And Corian had many arguments to. We tried some others materials. We analyzed concrete, light elements, and aluminium, and we made the decision for Corian because of yes, all the arguments were used and mentioned by my colleagues before, and one of them is you see, I think, on the next picture. Next. So, no, I think you have to go back. One more. I completely disappeared. Okay. So this is why the material offers, because it's so thin, it was perfect to have more space for the thermic insulation, so that we could comply with the regulations, the legal things in Luxembourg about the energy performance of the building. The other argument was that we were convinced by the possibility to use 2 panels assembled, and to get this height, and the panels are about 4 meters height and 240 in the other side, and you never see it's seamless. So we were happy to have this neutral material, and the way we studied the under construction was really efficient work with a contractor who came with proposals of always using simple and efficient solutions. Next. So the result is for us something from the geometry. We really like to work with strong geometry in our office, but also to mix it with a playful architectural treatment. So I think we create with this strong design. It's also speaks about articulation and joy in the design. Next.
And just a reminder, you've reached about 5 minutes.
Yes, it's just one picture still. Evoking shingles, Paco Rabanne dresses, and the next one. And this is the playful end on the rooftop. I'm done.
Thank you. Sonia.
Hello, thank you, Kat. My name is Sana Kovacheva. I'm part of STARH Studio since 2019. And I'm part of the creative department as an architect, and I will present to you Varna Wave project. This is a residential building, and Varna Wave is a special project for us. It is located in Varna on the Black, it's like the Black Sea capital, as we call it. Varna is the second largest city in the country. And Warnewave is also the building where our main studio is located at, and I'm currently right here. This is our first building with solid surface material and Corian in particular. We knew about the material for quite some time back then, and we were searching for suitable project in order to try it and to experiment with it. In 2014, when the investor came to us, when the investor Warnewave came to us, they already had in their mind this name Warnewave as a name of the building. And they were also quite forward thinking. So we knew right away that Corian is the right material for this project. At the time, no one ever used it as a facade cladding material in the country. And our information was from the local representative of DuPont, Mr. Alexander Banchev, that it was never used even on the Balkans until this point. So we traveled to Wrocław in Poland after he invited us in order to see 2 local projects, in order to understand how the material is implemented and how it's behaving. Next. With Warnewave, we were brave, but a bit cautious in design. The only bending that we used is at the corner of the building and along the railings, using just a single axis. After the completion of the building, we have received quite positive feedback from the builders who have worked on the facade installation and how easy it was to work with Corian. And now, almost 5 years after it got completed, we were quite happy and content with the actual result and how the material is behaving and still how good it's looking. Next. On the next slide, there's just one more picture of Warnewave. Yeah.
I think that that might be
it's okay.
Continue.
And since we're so happy with it still after 5 years, from every tiny street you see it hundreds of meters away, it pops out something peculiar you want to see closer. There was even one person living across the building just in front that even thanked us because thanks to Corian, not only they see something refined from their window, but now their living room is much more brighter than before, thanks to the reflected light. And you can go on the next. After Warnewave, we have used solid surface material for another 2 projects. This is BGA Corporate Building and B73 Apartments. With B73 Apartments, now you see it on the pictures, we were much more confident and freer in a sense of experimenting in shape and design. This is also a residential building. And now we are using more complex details and you can go on the next couple of next slides. And we were using now 3 different axes of bending. It got completed in 2021, and we hope that we will have even more opportunities to use Corian in the future in much more exciting projects like these ones. This is from me, and thank you. You can go from that for the final images if you want. Yeah.
Sure. All right. Thank you very much.
Thank you.
So let's discuss the future of facade design. What does it mean for you all? How are future technological changes impacting your work? So if someone would like to just comment on any digital fabrication methods or perhaps parametric design, these sort of digital advances, how is this affecting your work?
Well, yes, I can start sharing my thoughts. I mean, the building that I show has been one of our first attempts to venture into complex geometry. And since then, it was 2003 when we initially did the competition, the construction technology has evolved significantly. And also the overall imagery of the architectural form has, in a way, departed from, let's say, more traditional modernist shapes. And so this has given us at the moment a considerable freedom of choosing the best expression for our architecture, but at the same time, maybe to reconsider and go back to more suitable, well-tested and reliable systems, right? As a result of our exploration. And well, I have to say that in the case of the use of Corian, for instance, it has been extremely positive for us to rely on the opportunity of the material. There's more and more complexity ahead of us as designer with respect to the choice of a truly sustainable material, a truly sustainable technology. The technological system that might allow the best control over issues related to fire and safety and all these things. So it is really, I mean, at least to us, quite reassuring to have the support of important manufacturer that can, let's say, activate a serious campaign of testing and really invests into innovative solution.
Marie, do you have anything to add?
We work in a very in a historical center, so our contribution to the continuity of urban concepts don't allow us to put some imaginative station like you presented on. We love to work on smaller objects. When it goes to parametrical design, we made now a pavilion for a city in the south with the whole design, the computer. Yes, in many, but it's a smaller object. Now I would like to say that I totally agree with Filippo saying that our main efforts in the next years are going to choose for every project the right material at the right place with the combination of some sober use of energy, materials, and yes, and a certain local experience. And I think this is also what I so much appreciate. It's the cooperation with local knowledge and this simplicity of this slight bespoke joinery. The material can be worked very simply, makes that we will mostly use it the next years. Perhaps, yes, bent in one direction, but in designs which still are consistent with our former production and what the public and the society can accept.
Sonia?
Yes, well, when we speak about future of cladding material, future of facade fabrication and facade cladding, what is exciting for us here in the studio lately and what is making its way to the architectural and digital design is becoming the artificial intelligence and generating images quite quickly and easily. And if for quite some time back then, a couple of years ago, if we see some remixing of already known shapes, volumes, and styles, now with this artificial intelligence, as if a new door of possibilities is opening, which raises a lot of questions, a lot of issues that will need to be answered in future or in the present, probably, most probably. But the positive side for the architecture is that even if now the imagination of architects, it's even more enriched, it's going to be curious how the production industry of material production and facade cladding technologies innovation will somehow respond to this demand and maybe catch up with the new way of creating design between architects and AI.
Thank you so much for all of your comments. Unless any of you want to add more, we might move on to the next topic. And just a reminder to all of our listeners to include comments in the Q&A section if you have anything you'd like to ask the panelists. So there are certainly challenges in the implementation of facade projects with three-dimensional shapes, non-repetitive panels, complex geometries. Would any of you like to explore these challenges and your approaches? Filippo, why don't you begin again?
Yes. Sorry, the question is exactly?
Yes, so the challenges of implementing complex facade designs with non-repetitive panels, perhaps, or three-dimensional shapes.
Yeah, okay, sorry. Yeah, I mean, of course, I think I've mentioned this within my presentation. At the beginning, construction technology available for the production of facade was very limited, right? Because then the opportunity to bend in single curvature, not to say double curvature or torsion a panel, were extremely limited because just there was not demand for this complexity. We had the incredible case when we did the bridge for the Zaragoza exhibition in 2008, this incredible experience of working together with a naval manufacturer who was producing steel sheets of significant thickness, the same that would have been used for the hulls of the ships. And they had in-house the technology necessary to bend these like 80 millimeter thick panels into any shape, right? Because that technology was serving the purpose of producing ships' hulls, and therefore was already there. But because of the demand limited at the time in the facades industry, a very simple two curvature bending of a facade panel wasn't available. So it is quite reassuring seeing that in the last years, significant improvements has in a way come into the industry, and now the opportunity available are much more. But as I was saying, yes, now we definitely have to include in our agenda a number of other important aspects that are still waiting to be resolved.
Marie, would you like to continue?
Oh, not really, because it's a little bit redundant with what I've said before, and we haven't had the opportunity to experience this three-dimensional forming of these elements just on smaller design objects. I think, and I don't feel frustrated in any way for that, because Corian gave us fantastic opportunities in kitchens and to make crazy things. But I think let's see what happens in the next years. let me discover, and I know I would get some support from you.
True. Sonia?
Well, with our experience with 3 projects using solid surface material, and I can say that we are quite happy and maybe lucky to put into realization 2 residential projects that are using Corian solid surface material, because somehow in the context that we are, it's not that easy to introduce an innovative and the innovative material with higher cost. So we're quite lucky with responding to this challenge. In a sense of technical challenges, I can say that in Bulgaria, it's the production of the material and also the distribution of the material is really high level. Maybe what could be more needed is enough companies that have the skills and the expertise to actually make the facade installation and cladding. But that comes with having more and more projects in future. So hopefully this will change for everybody, not just for us.
Thank you for those thoughts, all of you. And Paco, we're going to turn to you. You have some solutions that you'd like to discuss?
Yeah, actually, as a producer of a material, interested in the quality implementation of the material, actually, we always try to get along with you, get along with technology, with what you do, not only the shapes, not only what I said earlier about providing a material which gives you a lot of freedom in terms of creativity, okay? But then we need to make it happen, right? I mean, how many times have you been told, you guys or anyone attending the meeting, hey, this is okay on paper, but how do I really make it, right? Like the guy that has to make it, how do we really make it? Well, we are also interested into that. That's why we put limits. We know the limits of the material, so that's why we say from time to time, hey, sorry, this might not be the right call, this might not be the right choice. With Corian, though, we try to always follow with 57-year-old material, okay, in hand. We need to stay up to date, and what we need to do is follow what you guys do, okay? You have an enormous amount of tools which allow you to create unique buildings, okay? It's probably very difficult because we are in the initial phases of parametric design. Well, initial, I mean, I think there's still a lot of room to expand parametrical design and computer design. Well, we had this feeling we needed to do something to help you realize what you had in mind. So we have developed what we call a 3D fabrication solution, a Corian 3D fabrication solution, which is a solution that allows us to go from your design to the panel in one step. So your 3D design in a computer passes into or becomes a real panel in just half an hour, 45 minutes, okay? You probably know the process of bending Corian. Bending Corian, or thermoforming Corian as we call it, means material up and then using a mold, okay, fixing it onto a mold until it cools down to room temperature. Then, of course, you have to trim it to size in order to have the right shape, right? Well, that's not easy, and it was not very easy. It's time-consuming. It's very difficult because just look at just an image, okay? We did develop this system to do things like what you see on the image. This was the first, the proof of concept, actually. We developed all of this solution, and this is the first proof of concept. It's 35 square meters, 64 panels. All panels are different. There's not a single panel which is identical to the other one, okay? So remember when we used to tell you in the past, like, hey, when we thermoform, we need to try to reduce the amount of different shapes so that we can do things on time and things can stay within budget, right? Well, with this technology, we can do single shape, unique shapes for every single panel, okay? The only thing we need to take into account is that it fits into the shape of the sheet. There are some limitations in terms of heights and angles and radiuses. But besides that, once you get your drawing, once you have the drawing, 3D drawing, we can bounce it straight away, fully digitally, by the way. We can bounce it directly into an adaptive mold, okay, which would reconfigure to the shape. We would thermoform the piece on top of it. Then we would have a post-trimming system that would trim the piece to size, and we will have a finished product. No molds produced. That means a lot of savings, environmental savings even, because most of the molds we would produce in order to produce these kind of shapes would be made with wood, okay? Just to give you an idea, barely for this project, we calculated that if we had to make the same project, same shapes with wooden molds, we would have used a bit more than 100 kilos of wood per square meter, just for this project, okay? So can you imagine the savings? It's also much faster, as you can imagine. We don't need to produce the molds, so it's much faster also. It could be up to 40% cheaper, end of the day, versus a traditional, let's say, fabrication method, okay? So with that, we think we have a very valid solution. I'm saying we have, because it's going to be available for all of you to use from October, end of October, more or less, that will be available for all of use. It is a technology that maybe, Filippo, if we have had this technology back in the days where you were working on the project of the Afragola station, well, those sentences we repeated back then, like, hey, try to repeat the same shape so we can control the budget and things like that. We would have said that, okay?
Yeah. Paco, yes, I mean, absolutely. I've seen this system at Rebuild in Madrid in the spring, and I was really, really excited. It was I was kind of emotional, actually, because I remember when we were doing the testing for the fire safety and the structural strength of the material together with the Corian technical office, I was discussing with Eddie Verschuren about the opportunity of studying a system of molds that could be reconfigurable based on pins or pistons and adjustable element that would be digitally controlled and allow all the possible double curvature shape. And at the time, it was more than 10 years ago, that was just a project. And then, yeah, you made it, you realized it. And this is incredible because this would have saved us a lot of concerns. I remember I was literally terrified when I was basically one of the very first designer with our office that was attempting to realize something in Corian without the reassurance coming from the contractor industry that those systems were possible. So if I had seen this particular system of molding the panels, I would have been definitely much more relaxed. For instance, I can see that those elements of Sania's projects in double curvature, I've seen something in black around the openings, would have been extremely easily to fabricate with this system. And yeah, at the touch of at the click of the mouse, basically you could reconfigure the molds and produce all the double curvature that you want. So yeah, well done, fantastic. Yeah, looking forward to use it.
Thank you, thank you, Filippo, for. Oh, sorry to interrupt. Kat, I just wanted to say that, of course, this is not only for external claddings. This can be also used for the internal claddings, or even for a singular object that you may want to produce. Okay, it's not only for. This is for the material. This is not only for one particular application.
So could you describe this first case study of this new technology available in October?
Yeah, well, this is what you see on the screen. It's literally the proof of concept. I mean, we really wanted to test if this was feasible. What we had in mind and what we had tested, like bits were positive on one side, some detached parts on the other side were also possible. We tried to put it together, and this is where we discovered that it worked. Well, it confirmed it did work. Okay. Basically, how it works is, as I said earlier, the architect made the 3D design. We had different meetings with the architect to let them know, with the architect studio, to let them know what the limitations of the system is. Okay, where? In terms of the size of the panel, because you see there, the size of the panel is pretty small because we had a small test unit. Okay, so we cannot go really big. Now we can go full scale. Full scale means panels of 3 meters 65 times 1 meter 50. So that's pretty big. Now, imagine those panels that you see in there, the curved panels you see on the right part of the image. They are approximately 90 times 55, more or less. So we could have done the same project instead of with 64 panels. Could have done this project with 10 panels only. Imagine the savings in terms of structure, in terms of installation, in terms of fabrication also, because it takes the same time to make a small panel than making a bigger panel, more or less the same time. There's a very little difference. And if you go to previous pictures, you will see that we display Corian in a very standard way, like flat, okay, as a contrast on the new fabrication methods that we can use. I mean, 10 years ago, probably, Filippo, it was like very unlikely to have something like that. There was some bits of technology here and there, and putting that together meant a big effort from our technical team. We did not do that in the last 6 months. Okay, took a while, took a long while to do it, especially because we wanted to do something really easy, so that what you design is what happened at the end.
Yeah.
Okay, I don't know. I know very little about 3D design. I can do these panels. If you do the designs for me,
Good.
Good. So unless any of the other panelists have any other thoughts, we can move into the Q&A portion. So we have to wait.
I have a comment. This seems like a really impressive new technology, and regarding with what I was just saying before, this seems like really good timing, because now with new possibilities of ideas, shapes, and design and imagination through different instruments like AI, now the construction industry and the facade material construction industry answers to this demand. So it joins really well together, having more unique shapes of panels and having less wood waste, being more cost effective. So this sounds really great. So I hope we will have the chance to use this technology in future.
Well, if you want to explore this new solution, okay, should you have any project that is suitable for this, or this solution, this fabrication solution is suitable for the project, hey, contact us and we'll analyze it with you. We'll have a look at it together with you, and we'll see whether it makes sense for you and if it's okay.
We will try to find a project then.
Well,
Yeah,
we are here to help you. Okay,
I just
this is
had
our
one
job.
question.
Yeah.
What is behind the panels? Do you also fabricate with the 3D design the supports? If you, or is it has it been a very exceptional facade and it doesn't matter what is behind this molding? How is?
But it is important, because at the end, a facade has to withstand winds and movements of the buildings, etc. It has to comply with the building codes anywhere you put that building, right? So behind that, there is a grid, a grid structure, very similar to the one you showed on your project. Okay, the only difference is that it adapts to different shapes of the panel, shapes and angles of the panels. Okay. But yeah, structural stability is of utmost important. It's not just about putting a sheet of Corian shaped in a way. No, we need to put that there also. We don't do that. We know about Corian. We can help you with Corian. We know companies, and we can help contractors to get in touch with companies that can do actually all the background structure, all the supporting structure.
Okay.
Of course, with the building, with the 3D drawing that you will supply, okay, that you will make, in reality, you have most of the job done already.
Yes, it should be already done. Yes.
That's the advantage of the of modern tools, or let's say the actual tools you use for designing. It means fabrication. It makes fabrication easier in reality. Very
That's
often.
true. We work also like everybody like now with BIM and everything exists very early in the concept phase in 3D with simulations, and it develops lots of possibilities. But the addition of complexity between the inside and the outside, and all those different things inside the facade, is something which is causing, for the time being, huge costs in the frames and supporting things. So I'm sorry to bring such a trivial aspect of things, because we are all thrilled by the possibilities, but still we have to be aware of the addition of couche. What's a couche? A sheet?
No, a layer.
Layer. Yes.
In reality, the main work of the technical team at DuPont, okay, is to say no. Yeah, we are the guys that say, sorry, but what you have in mind, it's not possible, because you need to take into account these and these and these, and that would make a safe installation, or it would make in a way that it will comply with building codes, etc. So we are the no guys. Yeah.
So let's meet sometime.
Yeah. We are very pleased to help you in any design you have in mind, any project you have in mind. Bring us in anytime you want. I mean, the earlier the better. Okay, so we can help you. I mean, very often it's just a matter of adjusting the size panel to change dramatically the price. Okay, because you can reduce dramatically the fabrication time, but just reducing a few centimeters the size of a panel. Okay, So we are there even for that.
Okay.
Right. So let's move on to the Q&A section. We have a question here for Sonia. It says, for example, how do you as a practice use technology as an enabler to realize your own style, beauty, and philosophy?
Well, we, as a technology, for us, is very helpful, all the building softwares that we use. And for example, with B73 apartments, in order to achieve this more, for us at the time, more bold shape and complex bending, we were trying a couple of different softwares in order to achieve this shape. And we put it at a test a couple of times in order to make sure for us that this is the perfect shape for the actual project. In a sense of technology, software technology is like that. In a sense of technology inside of the studio as a work process, it's the same thing always. In order to achieve and to follow our way of doing things, our own language, we always put our ideas to the test until the very end. And if we are sure a certain shape, a certain design, a certain volume, then we again try to put it in a test. And it's always a teamwork. And we are very trying to be perfectionists when we use to simplify our line. This is our way of process while we reach the design. I hope I answered.
Thank you. So there's a question. Could you please share the indicative cost per square meter for a flat standard facade panel?
I didn't get the question.
I think it's for Paco.
Okay.
Yeah,
I think so. Yeah, I thought so. Yeah. Well, it's very difficult to say. That's often a question we get from our colleagues in the sales department, and we don't like these kind of questions. I'll tell you why, because any single project is very different from one another. Okay, my experience tells me that finished price, so including the cladding, but also the installation and the supporting structure, etc. Minimum prices I've seen is around 230 euros, which is like $260 to $270 per square meter. Okay, but there are lots of factors who have an influence, who play a role in the cost per square meter. How easy it is to access the site, whether you fabricate the sheets. It's just a matter of cutting panels and putting them up in the facade in the building, or they need a lot of fabrication. So there are lots of things who have an influence in there. It's very difficult to tell a price. So let's say that an indicative starting price would be around that.
All right. Another question for Paco. All three designs were white or gray. Would color also be suitable for facade use?
Yes, yes, but we don't really recommend using all of the colors in our color range. We have like 100 colors, okay? We recommend the use of certain colors because of its better performance in terms of UV stability. We provide a 10-year warranty on color fading for facades, okay? A red, for instance, we cannot give this kind of warranty on red because it's going to fade more than what we guarantee. Okay, so one could use any color. Would recommend to go for colors that have a better UV performance. White is the best performer in terms of UV resistance, for instance. Okay. like in 20 years time, we could expect a delta 5 EAB in terms of color change, which is really minimal for 20 years. For all the colors, this color fading may happen earlier. Okay, so yeah, we could basically use any color in our range for the external claddings, but we would prefer to limit that to the best performance in terms of UV stability.
Someone would like to, would you explain the thermal expansion of Corian and how that's managed with connection detailing and seam dimensions?
That's could be easy and difficult, actually. Let's say the easy way. We always consider an expansion of 3 millimeters per linear meter. Okay, any direction. Okay, so that's why we need expansion gaps from one panel to another panel. Okay, size of this gap would depend on the size of the panel in reality. How do we get, this is one of the limiting factors in terms of the size of the panel sometimes in projects, because the limit actually of the feasibility of the project comes more from the background structure, supporting structure, than from the cladding itself. Okay, if we had a system which would make the Corian float, well, maybe that's going to come in 20 years, right? But if you want to mechanically fix it to the building, okay, this is really the limitation. So depending on the hanging system, there we would have more limitations on the size of the panels or less.
Someone is asking if it's possible for Corian to be recycled.
Yes, but it's not the. It's probably not the best way to make it a sustainable product. I'll tell you why. Because we have to strip it and bring it back to our factories. And our factories are in every corner of the world. So depending on the part of the world where the costing comes from, that might be, a bit far away from an environmental point of view. I doubt whether that's going to make, it's going to make sense or not. Corian can be reused and recycled. It can be reused just by sanding it. You will get your surface clean as new, literally, so you can use it for many other applications.
And then I think we have time for one last question. Someone asked for Filippo, when does the technology Corian start influencing the project? Do you know what you can use and its possibilities when you start, such as for the Napoli train station?
Sorry, this particular technology that we've seen.
When does the technology with Corian start influencing the project?
Okay, yeah, of course. Well, no, I have to say that we were exploring that very shape since the beginning. That was really, part of our overall initial idea, and we've been looking after for the right material to implement it. We didn't shape the building directly on the construction technology, as we've done normally in the most of our projects, because we believe that innovation is always, let's say, the range of innovation is always wider when it's not specifically goal directed, so that there are a number of unexpected opportunities for unpredictable aspects of the project that can be discovered along the way, and open the way to streams of innovation that are not invisible at the beginning if you if you proceed towards a specific goal. If this was clear enough.
Thank you. So that's all for today. Our conversation will be available to rewatch on both Design Boom and on Arc Daily shortly. In the meantime, I'd like to personally thank each of our experts for adding their own professional perspective on the future of facade design. For those interested in finding out more about the case studies, as well as other projects by our participants today, their work can be found on Design Boom as well as on Arc Daily. More information into Corian Design, their products like Solid Surface, and the upcoming digital fabrication technology and services can also be found on both platforms. We hope you enjoyed this talk, and stay tuned for our next in the 3-part webinar series focusing on healthcare.